Hi everyone, myself Rekha, Assistant Professor, Department of Mathematics. So today we are going to discuss about the topic queuing theory in the course Resource Management Technique. So first of all, we are going to discuss the queue model m/m/1 n f5 f4. So this is nothing but first model in that single server and first in first out. So there will be a finite number of customers will be arrived, so that we are going to discuss. So before going to that, so what is queuing theory? Once again I recall. So queuing theory is nothing but an waiting line of a customer. So waiting line is nothing but it varies in waiting for service in banks and reserve for reservation of counters and for the train or bus, then checking out of the supermarket telephone booth, and the customer arrives at the service facilities. There are the different forms of the customer that help us for the waiting line, and as well as the customer feel discomfort either mentally or physically. So these concepts we are going to discuss in the queuing theory. So before entering into the queuing theory, we have to know what is the basic definitions of the queuing theory. So first is customer queue arrival distribution. Customers is nothing but the arrival unit that requires some service to be performed. Queuing is nothing but the number of customers waiting to be served. Arrival distribution is the jobs or person entering in the system is to be customer to the system. So these are the concept we are going to discuss in the queuing theory. Next is basic definition. Service distribution is nothing but it describes the pattern by which service is provided to the customer, by which the customer leaves the system, and the service pattern may be a constant or else a random variable. FCFS is nothing but first come first served. LCFS is nothing but last come first served, and third one is random selected, and last one is selection based on the priority. So these are the basic definitions involved in the service discipline. Model 3 is nothing but generally queue model can be completely specified using the different models, and that is m/m is a variation of the queuing model used in the queuing, and the first and second symbol denotes the system of distribution, and n represent the finite number of customer. Let us consider the model problem. If a period of 2 hours in a day, the train arrives at the yard every 20 minutes, but the service time continues to remain 36 minutes. So the probability of the yard is empty, means we have to find the average number of trains in the system. Let us assume that the limited trains 4 only can wait in the yard. So first you have to find always we have to find the arrival rate and as well as service rate. Arrival rate is nothing but lambda, that is 20 minutes one train is arrived. For 1 minute 1 by 20, so that we are going to calculate. Then if you go with the service rate, means 36 minutes for one train, means one train is serviced for 36 minutes. Mu can be calculated as 1 by 20 by 1 by 36, so 36 by 20. So now we are going to arrive that P naught equal to P minus 1 by P power n plus 1 minus 1. So that is nothing but 0.8 by 1.8 whole to the power of 5 minus 1. So that can be calculated as 0.04470. And E of n equal to e power 4 n P naught. So P naught equal to 0 into P naught plus 1 into P power 1 plus 2 into P2, 3 into P3 plus 4 into P power 4. So 0.045 into 0 into 1.8 plus 1 into 1.8, 2 into 1.8 whole square plus 1.8 whole power 3. So multiplying 0.45 it is a common, and we will get 0 plus 1.8 plus 6.48. Adding all the values you will get 67.748. So 3.102. So totally 3 trains can be arrived 0.04470. So these are the problems. So we can connect using the queuing model. So the queuing model is there is another model, that is model 1 we are going to see, and the TV problem. and in model 1 infinite number of customers can arrive, but in this model 3 we have to note it that only a finite number of customers can enter into the system. Already I have mentioned that only 4 trains or else 5 customers, like that one the limited customers only allowed in this system. So based on that limit only we can solve using the queuing system. So next model we will see the model 1, and more problems can be discussed in the next, and you can solve as a assignment problems also. So thank you students for watching this video.